Lesson 56 time. Identifying, writing, and graphing direct variation. Now I'm doing these out of order, so I've already done lesson 64. And when you get there, there'll be a summary of direct variation and then the kind of variation that's introduced in that lesson, which will be called inverse variation. So there'll be more coming about this this concept here. So we're going to talk about it for a little bit. I want to try to give you a fairly deep understanding of what's going on here and then run through the various examples and what to look for. So it says we're trying to identify, write, and graph direct variation. Direct variation is when you've got two variables and they're changing. Okay, one's going up, and what happens to the other one? Does it go up as well, or does it go down? Does it go in the opposite direction? Direct variation is when you have two variables like x and y, and as x is increasing, y is increasing as well. And it happens in a constant way. So I'll give you some conceptual things to think about here. But first of all, if you can write a problem in one of two forms, okay, first form would be like a linear form, y equals x and k, or maybe we should say k times x. And that's kind of our normal draw a line kind of form without the plus b part of it. And in fact, equations that are of this form, y equals a constant times x, are direct variation problems, are direct variation equations. So if it's y equals 2x or y equals negative 3x, because there is a constant, that k there stands for the constant of proportionality, you'll have a something that's increasing or decreasing in a constant way. Just a straight line is what you want to look for when you've got a graph of this. Maybe that hits that third thing there, graphing direct variation. You're always going to have a straight line drawn. There's a couple other things I want to get to with that, but that's the first thing. Y equals k times x, where k is the constant of proportionality. Or the other way would be write it as a proportion. Y divided by k is always a constant. So let me give you a couple of examples for that. Maybe your y value is 10 and your x value is 2. Okay, that ratio, 10 to 2, equals 5. So that if y were to increase to 20, x would have to increase to 4 to keep that same ratio constant. Okay, so you can think of it as a line, or you can think of it, or an equation, or you can think of it as a ratio. And we're going to think about it both ways because both of those are true. See, the only thing that's different about these two is that here, maybe I've just divided both sides by x, and the x's would cancel out on this side, and you'd have that equation left there on that side. So I'm going to go back and leave it like this so we can see both of them. Those are both ways of writing proportionality, variation between two variables, the relationship between each other. They have a constant of proportionality. So it describes two variables and how they relate or change. And let me give you a really quick example. I'm leaving on vacation here in about 3 or 4 hours. And as I'm driving, I'm always trying to make the best time up to Oregon as possible. So I'm always looking at how long we've been on the road and how many miles that we've traveled. So those are the two things that you look at when you think about your rate, when you think about your speed. Even when we talk about speed, we say miles per hour. Okay, miles per hour. If I was going to graph that, my distance would be on the vertical axis, and my time would be on the horizontal. So this is like x, and this is like y. And what we do is we compare the two of them, that if I'm going at a constant rate of, let's say, 60 miles an hour, in 1 hour, I should have gone 60 miles. In 2 hours, if I can maintain that rate, In 2 hours, I should have gone 120 miles. Oh, this is not going to turn out so straight. And in 3 hours, that should mean I've gone 180. And when I connect the dots here, I'm trying, what you should get is a straight line. You should get a straight line. Because our rate of change, or our speed, are miles per hour, 60 over 1, 120 over 2, 180 over 3, is a constant. If you want to think of it as slope, that is always going to be the same no matter how far I go up and how far I go over. That slope right there, that angle, is always going to be the same in things that are direct variation. Okay, I'm going to clear the board here and put some more stuff up. We'll talk you through some of the examples that are in the lesson. All right, that was a little weird. Okay, so I got 3 things from example 1 here. And really none of these look like this or that, do they? With the y on top and the x on the bottom. So are none of these direct variation? Why would they give you an example where none of those are true? All of these top 2 can be written in this form or this form, okay? And that's the thing, is that basically what your goal is probably to get it in a form like this. It's the easiest to see and it's the easiest to graph. You're used to graph, so let's go ahead and do that. If we can get this in the form of y equals and the other stuff on the other side, we can look at it and see, does it look like this or does it not? So this first one, y plus 8x equals 0, we know that if we want it in the y equals form, everything else on this side needs to move to the other side. So we're going to take the 8x and we're going to move it to the other side, and here we have our y equals. And there's no plus b there, which is exactly what we want. We see that here we have y equals k is negative 8 times x. That's exactly the same form as that one right there. So this one is direct variation. You could graph it and it's like that, straight line. Now this one doesn't look like the right form either, but it kind of looks like this, doesn't it? But we're supposed to have our constant over here, and we're supposed to have our x down here. And that's easy enough. We can do the same thing to both sides and move the x and move the 10 to opposite sides. So we can multiply both sides by 10, and then we can divide both sides by x. And the 10's cancel out, the x's cancel out, and that'll leave us with y over x equals 10 is an equivalent, it's a different form, but it's equivalent value to the original expression of y over 10 equals x. Well, I always think of it as, if I'm going to move something from one side of the equation to the other, it has to travel through the equal sign. So if it's in the numerator here, it has to go into the denominator. If it's the denominator, it has to move through the equal sign and end up here. So this fits this form right here, so yes, that is direct variation. Their third one is a problem, though. Their third one describes the other type of variation, which is called inverse variation. There's no way that I can get this into either of those 2 forms, because here, the constant of proportionality, 6, is actually the product of x and y. And product is the word that we look for when we are doing the other type of variation in a lesson 64. We're looking for something that's a ratio. And it's not that way. It's not x divided by, or y divided by x. It's x times y equals 6. So this one is not going to count. In fact, if you start picking some numbers for x and y, if x is 1, then y has to be 6 because x times y equals 6. If x increases to 2, we see that y has to go down to 3 because 2 times 3 is 6. And if x goes to 3, then y has to go down to 2 because 3 times 2 is 6. We see another problem here if I graph these out. 1 would go with 6, 2 would go with 3, 3 would go with 2, and this is not going to make a straight line. It's going to make a curved line, which is an obvious indication that we are not dealing with direct variation. direct variation always gives you a straight line on the graph. Okay, I'm going to clear the board again and go to the other examples. Okay, example 2 gives you some ordered pairs. Gives you the pairs 2, -14, 5, -35, and -321. And if you had a really huge amount of graph paper, then you could plot those out and see if they're on a straight line. But you can't very easily do that with these 3 dots. So what you can do is you realize that this is the y and this is the x. And if these 3 all go together, then y divided by x has to be a constant. That's what this rule right here says. So if we take the y value divided by the x value, we get -7 for that first pair. The second pair, we get -35 divided by 5, and that equals -7 as well. So that's 2 out of 3. And we can see here that 21 over -3, that one's going to also be a -7. So since all 3 of them have the same ratio of y to x, we have direct variation. So that's all you do. You're going to take your y and divide by your x, y divided by x, y divided by x. If they are the same, you have direct variation because y divided by x has to be a constant in this type of problem. Example 3 says, what about at one specific point? Okay, now one thing that's true about these, they come in this form if we're going to think of them like an equation now. And you notice that if this was like mx plus b, m is my constant of proportionality, but there is no b in these problems. It's basically a line with an intersect of 0. That means that it starts at the origin. If I'm going to graph it, it has to start right there. And x will increase this way, and y will increase that way. But this is one fixed point that's always on your graph. So if we go to 624, it'll be somewhere way up here, and make a straight line between them. Basically, this is enough information for you to describe that constant of proportionality or the slope. Okay, so what we have here is 24 over 6 is that constant, and that equals 4. So I can go back to this original equation. I'm going to change that the slope or the constant of proportionality is 4. And there's my equation given that point. It's going to go through 0, 0, and then it's going to go through the point given. So if we take that xy point and look at its proportions, we can find out what the constant of proportionality is and rewrite that as an equation. Lastly, in example 4, they give you some stuff that I call before and afters. Because this constant of proportionality always stays the same, we can write this type of problem in a new form. And we'll call, this side the before side, and this side the after side. We'd say at first my proportionality was, let's say, 10 to 1. But now that 10 is increased to 20, so what's the new x value? You can write it as a proportion. This kind of thing happens a lot in chemistry, and it happens with what's called the gas laws. And with gas laws, they always tell you the original conditions that you're dealing with, and then they tell you how one of these things changed, and you have to decide what happened to the other one. So this is one of the gas laws that involves pressure and volume. As the pressure increases on something, its volume gets better. You think of blowing up a balloon. You push harder, and it spreads out. So if you push even more, you apply twice the pressure, the volume should go up by twice as much as well, because that ratio of before and after has to be a constant. So in those types of problems, they will always give you 3 of the numbers, and you figure out the 4th. Okay, that's enough information there to set up a ratio to solve for the missing piece. So again, if this was 10 and this was, let's say, 2, and they told you that the volume increased to 6, then you've got some basic math you can do to solve that problem. 10 times 6 divided by 2 equals P2.